Today we're going to talk about screw path and decoupled path. For a screw path, it is a straight line path that the twist is constant throughout the motion. And another type of path decouples the rotation and translation. The origin of the frame follows a straight line and the rotation is about an axis fixing the frame. Here we got two animations representing two different types of path. The first one represents the screw path, and the second one represents the decoupled path. Now we can run the simulation for the animation one. And here you can see the twist is constant throughout the motion. And now we run animation 2 to see what happened to decoupled path. And here you can see the origin of the frame follows a straight line, and the rotation is about an axis fixed in the frame. And there are two types of timescaling, quintic timescaling and cubic timescaling. Let's shift to cubic timescaling to see what happens. So for quintic timescaling, the initial and final acceleration are all 0. And for cubic timescaling, the initial and final velocity are all zeros. And let's see what happens to the animation 2. We can manipulate the parameters like frames to see what will happen. So if we increase the frames, the intermediate points will be increased too. So as you can see, those points are getting larger. And now let's see what happens to animation 2. So those intermediate points are increased since we increase our value of frames. Here we increase the interval value to see what will happen. Basically, the interval value determines the time it takes to draw each point on the graph. So as you can see, as we increase the interval value, the time it takes is much longer than before. And here is animation 2. And we can see it applies to animation 2. We can also change the start position and end position, and also the start rotation and end rotation, and the graph will be different